Are you looking to strengthen your knowledge in bioprocess engineering? Whether you're a student, researcher, or industry professional, Bioprocess Engineering Online offers a series of free, expert-led video tutorials that guide you through the effective use of spreadsheets in bioprocess engineering. In its courses, Bioprocess Engineering Online makes uses of a wide range of dedicated spreadsheets to analyze experimental results, to model and simulate bioreactors, to scale up and optimize bioreactors, to design integrated bioprocesses, to evaluate their economic and environmental performances, to perform sensitivity and uncertainty analysis. Explore our growing library of tutorials that learn you the use of spreadsheet for the analysis, simulation, scale-up and optimization of enzymatic bioconversions, microbial fermentations, and animal cell culture processes. Spreadsheets are digital tools that organize data into rows and columns, forming a grid of cells where users can store, calculate, and analyze information. Using formulas and functions, they make it easy to perform calculations, visualize results, and model complex processes. Spreadsheets are powerful tools for analyzing experimental kinetic data generated in the laboratory. They enable rapid calculations, clear data organization, and intuitive visualization of biological and physical processes. In tutorial fermentation kinetic analysis, learn how to use a spreadsheet to analyze experimental data from yeast growth and substrate consumption in batch culture. You will also learn how to numerically estimate specific growth and consumption rates throughout the fermentation. In tutorial microbial kinetic analysis in continuous fermentation, discover how to analyze kinetic data from continuous cultures under substrate-limited conditions. You learn how to characterize the effect of nutrient limitation on cell growth and metabolite production. In tutorial cell culture kinetic analysis, learn how to process experimental data from animal cell cultures and quantify key kinetic parameters, including cell growth and death rates during batch operation. Spreadsheets are powerful tools for developing knowledge-driven simulation models of bioreactors based on the underlying biological and physical phenomena. In tutorial microbial fermentation simulation model, discover how to use a spreadsheet to build a simulation model of a yeast fermentation and numerically integrate the governing equations to predict process dynamics. Spreadsheets are convenient and powerful tools for scaling up bioprocesses from laboratory to industrial scale, while accounting for scale-dependent effects on biological rates, mixing, agitation, and mass transfer. In tutorial digital scale-up of yeast batch fermentation, learn how to use a spreadsheet to perform digital scale-up and optimize a batch yeast fermentation, with the goal of maximizing reactor productivity and substrate conversion yield. Spreadsheets also support the design of complete bioprocesses, integrating both upstream and downstream operations. They enable efficient evaluation of material balances, energy requirements, and equipment sizing, providing a clear and quantitative framework for process development and decision-making. For bioprocess optimization, spreadsheets are powerful tools for assessing both the economic and environmental performance of integrated bioprocesses, encompassing upstream and downstream operations. In tutorial lifecycle assessment of bioprocesses, learn how to carry out a bioprocess lifecycle assessment, LCA, using spreadsheets designed to handle material and energy inventories, as well as to evaluate environmental impact indicators. Finally, spreadsheets are also powerful frameworks for carrying out sensitivity and uncertainty analyses in technical, economic, and environmental studies. They enable you to explore how variations in key parameters affect model outcomes and support more robust and informed decision-making. All our spreadsheet tutorials are available on our Bioprocess Engineering Online YouTube channel and on our website, bioprocessengineeringonline.com.